in the program scientist Of these objects viewed in different wavelengths. On the top left-hand corner is an image of the is an X-ray image of the Crab Nebula, and you can see that the X-ray goes right through the heart of the Crab Nebula, and you can see the motion of the particles in the rings of the nebula. This nebula was first observed by the Chinese in 1054, who thought it was a star. Can you still stay in the previous slide? The object on the top right-hand corner is a star Zeta or Pucci, observed by Spitzer. This star is obscured by dust, but the infrared light of Spitzer allows us to see the details that the hot winds from the star push out the dust in the form of a bow shock. In the lower left-hand corner is a Hubble image of the Ring Nebula, and we are able to see a lot of details in the ring of this nebula. On the lower right-hand corner of the star is a composite image of push out the dust in the form of a bow shock. In the lower left-hand corner is a Hubble image of the Ring Nebula, to see the entire light, to see a lot of details in the ring right from birth to the lower right-hand corner of the star is a image of push out the dust in the form of a bow shock. In the lower left-hand corner is a Hubble image of the Ring Nebula, to see the entire light, to see a lot of details in the ring right from birth to the lower right-hand corner of the star is an image of push out the dust in the form of a bow shock. In the lower left-hand corner is a Hubble image of the Ring Nebula, to see the entire light, to see a lot of details in the ring right from birth to the lower right-hand corner of the star is an image of push out the dust in the form of a bow shock. In the lower left-hand corner is a Hubble image of the Ring Nebula, to see the entire light, to see a lot of details in the ring right from birth to the lower right-hand corner of the star is an image of push out the dust in the form of a bow shock. outside the cryogenic chamber at Johnson Space Center, where it was tested with the entire object. And see this chamber it is coming out of? That chamber was originally used for the Apollo missions and it was modified picture of the telescope outside the cryogenic chamber at Johnson Space Center, where it was tested with the entire object. And see this chamber it is coming out of? That chamber was originally used for the Apollo missions and it was modified picture of the telescope outside the cryogenic chamber at Johnson Space Center, where it was tested with the entire object. Many of you must have seen it. It was coming out of that NASA on February 11th, the Apollo missions. Picture of the telescope outside the cryogenic chamber at Johnson Space Center, where it was tested with the entire object. Many of you must have seen it. It was coming out of that NASA on February 11th, the Apollo picture of the telescope outside the cryogenic chamber at Johnson Space Center.
रीस्टार्ट कर रहे हो
Tested by the entire object. Many of you must have seen it. It was coming out of that NASA on February 11th, instrument infrared telescope outside the cryogenic chamber.
का नहीं चल रहा है नेटवर्क, इससे मैं कंट्रोल कर रही हूँ एक से।
The aspect is provided by the European Space Agency. The NIRIS is provided by Canadian Space
क्या बोल
Agency and
मैं अगर रिसेट करूँ तो
NASA outside the cryogenic
का नहीं चल रहा है नेटवर्क, इससे मैं कंट्रोल कर रही हूँ एक से।
are used to study different aspects of the cosmos. Here's a picture of the agency
मैं अगर रिसेट करूँ तो
footprint of the instruments, different parts of it, showing
का नहीं चल रहा है नेटवर्क, इससे मैं कंट्रोल कर रही हूँ एक से।
each instrument will deliver aspects of the different parts of the galaxy. Next, please. Here's a picture of the agency.
मैं अगर रिसेट करूँ तो
So, as I mentioned, there are these four instruments. This aspect will study many distant faint galaxies. This is the first space telescope to have what we call a micro shutter. So, and this, as I mentioned, there are this has instruments, lots of tiny little shuttle-like windows which can be opened and closed as well. So, in one image, you can, in one shot, one can get a shutter. Dozens of objects, a spectra of dozens of objects at the same time. And it's really fast. The near infrared.
ऑडियो कैप्चर एक मिनट नीचे ऑप्शंस आ रहे थे ना, ऑप्शंस खोलना। ऑडियो कैप्चर इसमें नहीं, बाहर ही ऐसा स्टैट्स वगैरह कैसे आता है? ये देखो नीचे क्या है ये?
हाँ
वो उसके बगल में प्रॉपर्टीज के बगल में। Forces.
Spectroscopy and the mid-infrared instrument, spectroscopy and imaging includes feeder objects like debris around stars and other objects that emit mid-infrared light. Next, please. Next. Next, please.
ऑक्सिलरी ऑडियो को बंद करो जरा। एंड ऑक्सिलरी ऑडियो थर्ड ऑप्शन जो है ग्लोबल ऑडियो डिवाइसेस में।
Okay, so where is
इसको नहीं इसको थर्ड ऑप्शन को।
while the the Earth, in what we call the Earth orbit, about 300 miles from the Earth.
ऑडियो को बंद
The
करो
Webb is
ऑक्सीलरी
almost a
ऑप्शन
million miles from Earth at a semi-stable point called
इसको नहीं इसको
L2. Webb
थर्ड ऑप्शन
orbits L2, and with it, it orbits the Sun, and its sun shield uh, is always facing the Sun to protect the Webb from the heat of the Sun and the Earth. Could we have the next slide? Could we have the next slide, please? So here we can see the two sides of the sun shield. The side which is on this facing the telescope is the cool side. It keeps the telescope very cold, which is required for an infrared telescope, so that the light so that the heat from the telescope doesn't interfere with the light from the objects it's viewing. And then on the hot side, is the the side which faces the sun. It has the solar array and the communication antenna. That's the sun-facing side. Next slide, please. Next slide, please. Next, please. So here the Webb's unfolding sequence. I don't need to say anything about it. It's already been done. Could we have the next slide, please? So how do we talk to Webb? So the operations center for the Webb telescope is at the Space Telescope Science Institute in Baltimore. So the commands from Baltimore are sent to the Deep Space Network in Goldstone, California. And from there, they are transmitted to Webb, and then Webb receives them from its communication antenna, and data from Webb is communicated back to the DSN, or the Deep Space Network, which then conveys it to Space Telescope Science Institute in Baltimore. Next. So Webb is an international collaboration. I already mentioned that we have partnership with the European Space Agency and the Canadian Space Agency. And on this map, it maps the 29 states in the United States, as well as the 14 countries which have a partnership in it. Thousands of people have worked on Webb, and it has been built at a cost of about $10 billion to the US taxpayer, plus contributions from the European Space Agency and the Canadian Space Agency. So it's an investment which is going to pay back in spades. So next, please. So we are now in the Webb commissioning process, which will take a total of about 6 months. We have finished the launch, sunshield deployment, mirror deployment, arrival at L2, telescope cooling, and are now doing the telescope alignment, after which is instrument calibration and first images in June of this year. Next. So here are just some fun pictures where Webb started its journey to the launch site. A special container was built for it called Space Telescope Transport for Air and Road Stars. And here you see it loaded in that big container, and it's starting to roll out of the Northrop Grumman facility in Redondo Beach, California. Next. It was placed in a ship, M.A.N.I.T Colibri, which passed through the Panama Canal, and here it is approaching Kourou, French Guiana, in South America, from where it was launched from the European spaceport aboard the French Ariane 5 rocket. So this was a contribution of the European Space Agency, the launch. Next, please. Here's the perfect launch on Christmas Day 2021, which I hope many of you saw, and if you didn't, you can go to NASA YouTube and see it. And excuse me, and Webb is now in its orbit around L2. Next. This is a goodbye picture as Webb is leaving the rocket. The picture was taken from the rocket, and so it's a really nice picture of the actual telescope leaving. Next, please. And here is the progress of the focusing of the telescope. In the first picture on the left is the initial alignment when a star was acquired by all the 18 mirrors of the telescope. In the second, the mirrors were adjusted so that the image of the mirror is at the center of each of those mirror segments, the 18 mirror segments. And finally, the mirror segments have been adjusted so they all focus together at one point, which is what we've been looking for. It is now in what we call a coarse focus, and and it is being we'll be getting the final focus, and then the instruments will be calibrated before we get the first science images. Next. And so I'd like to leave you with a final thought of what will be the real scientific discovery potential of Webb. So on the top of the diagram are the 4 science questions that Hubble had been designed for. And in the lower part of the diagram are the 4 science questions, the 4 science goals that Webb had been designed for. If we go to the next slide, but you will see that in addition to the 4 questions the previous one, please. In addition to the 4 questions that Webb was designed for, it answered many more questions, it discovered many more scientific discoveries than we were even aware of that existed. We didn't even know exoplanets existed when Hubble was launched. We didn't know about dark energy. We didn't know about super black holes, gamma ray bursts. And Webb discovered a lot of those things and gave us a lot of knowledge about things that were discovered by other telescopes. So what will Webb tell us other than its scientific goals? That, in my opinion, is the most exciting thing that I am waiting for. What is out there that we still don't know about, and Webb will show us. And I hope some of you in the audience will be submitting proposals for observations for Webb. And even if you don't submit proposals, could I go to the next slide? You can still analyze the Webb data, because all the Webb data will be archived at the Mikulski Archive for Space Telescopes in Baltimore, Mass. The data is available to the public. Anyone can analyze Webb data. So I would encourage you all to do that. This also contains data for Hubble tests and a lot of other missions. So if you go to the next slide, I will leave you with some websites about Webb, which you can go to learn more about Webb. And, and so with that, I'll open it up to questions. I think we have a few minutes for questions. Thank you.
So as we can see, we have experienced recently a dynamic situation where we can observe what are the different aspects of this James Webb Space Telescope, what all perspectives we can desire, what all aspirations we can fulfill. This all scenario have been live in front of our eyes only because of respected Dr. Hashima Hasan ma'am. I am really fruitful to achieve this particular platform in a way that it has enhanced my vision towards the space adventures. We keep on watching the movies. They involve a lot of sci fictions. However, they present us a different view. But talking about something which has its existence, it is a different scenario. That scenario with the collaboration of NASA and to the eminent personalities who are working 24 hours to make that thing real, to make ourselves realize where we came from and where it all started. That is a part of science which is yet to be explored. And I think who understand science, who believe in science, also believe to see how we existed before and how we are going to carry on the existence on our shoulders to our upcoming generations. So, if there are any more queries from any of you, you may ask it. We are here to solve your curiosities rather than saying them queries, because this is a subject which can enrich the curiosity in yourself rather than making some questions in your mind. So, is there any curiosity to anyone? Feel free to talk about that. I think the crystal clear presentation, the crystal clear dialogues are enough to settle every curiosity, every query that comes in our mind. Rather than, I believe that this can be a stimulation which will help us to stimulate an idea in our mind which will pave the way towards the future. If there is any queries in your mind that comes afterwards, you should go after your queries, make them a reality, and I think that will enrich the analytical mind in yourself. Now, concluding this meeting, I am thankful to ma'am and to the other persons who have involved themselves in this meeting. For Thanksgiving, I will like to invite Kajol Taibade. She is an eminent research scholar in Department of Physics, working here under the supervision of able guidance. So please, Kajol, present us with a vote of thanks.
Am I audible? Okay. Thank you so much, ma'am. Gratitude unlocks the fullness of life. It turns what we have into enough and more. It turns denial into acceptance, chaos to order, confusion to clarity. It can turn a meal into a feast, a house into a home, a stranger into a friend. Gratitude makes sense of our past, brings peace for today, and creates a vision for tomorrow. A wonderful evening to our colleagues here in India and a soulful morning to the personas in the USA. The talk given by respected Dr. Hashima Hasan ma'am has inspired us with the river of knowledge, which not only quenched our thirst of curiosity but also engraved our minds with dynamic ideas and visions. I'm heartily thankful to our patrons, Honorable Director Sir, his aspiration to coincide the query with the solutions has provided always a myriad of opportunities to all of us. I feel deep gratitude to address thanks to our respected Professor Manmohan Kapse Sir, Dean Research and Consultancy, Professor Arvind Mittal Sir, Dean Academics, all the other deans, HODs, professors, and faculty for their potential guidance and encouragement. The bar of your knowledge has made us speaking in this context of education. A leader is one who knows the way, goes the way, and shows the way. This famous quote by John Maxwell is worth remembering at this moment, and I'm sure everyone can correlate this quote with our coordinator of this event, Dr. Fozia Zia Huffman, Head and Associate Professor, Department of Physics. Her act of grabbing the opportunities has been beneficial for all of us. We're thankful to her efforts and may she live long to guide us. I'm also thankful to all the faculties of Department of Physics, to my colleagues and the supporting staff who made this event a success. Thanks to all. With this, I'm ending this session. Thank you so much.
Thank you, Kajol, for your wonderful words. So, in that context, we have some, actually, I can say one query in the comment that is, I think I can make it audible to everyone. I have heard somewhere that this telescope would be placed in an orbit so that it is hidden from sunlight. Why is it so? So I would like to address this query to respected Hassan ma'am, if she can answer the curiosity of Seychelles.
So this telescope is optimized for infrared observation. Now, infrared, as you know, is emitted uh, by our bodies, by every object, by the telescope itself and its science instruments as the heat of the earth, the sun, and all those objects. So we want to look at the infrared light from from the objects in the galaxies that we are studying. And we don't want the extraneous infrared light to interfere with it. It's like noise. So if you're trying to hear a sound and there's a lot of noise going around, the signal is lost in the noise. So we have to get rid of that noise. And so that is the extra outside heat, the outside infrared radiation. So that means everything has to be kept extremely cold. The warmer it is, the more infrared it radiates. So for that reason, it is sent far away from the earth, as far as it can be sent to keep it cool and yet be able to communicate with it. And then whatever other radiation reaches there, which is really quite a lot, is protected by the sun shield.
Thank you, ma'am, for addressing the query, the curiosity that the session Mr. presented. I will like to end this session, but before that, there is one small query from Ganda Varun Reddy also. He is asking a simple question. Does this telescope reveals information about other solar systems present in the universe? That is the question, ma'am.
Yes, that's what we call extrasolar planets. And I had it on one of my slides, but I think went through it very fast. It will look for extrasolar planets. So the planets are cool, so they radiate in infrared, whereas the stars, they orbit are very bright and they don't radiate in the infrared. And the Webb cameras have something called a coronagraph, which blocks out the light from the stars. And the light from the planets is able to reach, excuse me, is able to reach the telescope. And so there are various, scientists have developed various techniques for detecting extrasolar planets. And Webb will certainly be able to detect them.
Thank you so much, ma'am. I think we have looking up to the new dimensions of this particular technology, and I am hopeful that there will be so much queries, many more, but they need to sort it out on their own effort. In that way, you will be qualifying the word research. Okay, so with that, I would like to conclude the session, and I would like Dr. Fozia Ziahat, ma'am, if they want to say something to the audience.
So,
Ma'am, you are muted. Yes. Okay.
okay, so I would like to thank everyone at, I don't know how you call it, M.A.N.I.T, and Dr. Khan for her kind invitation, Dr. Bharka for his very kind introduction, and to all the professors and at M.A.N.I.T, and of course the students who are the most important audience here and who are the future of India and indeed of the universe. You are really the most important audience here today. And I hope I was able to give you some idea, some glimpse of the kind of work going on over here with the Webb. And I'm sure several of you will be working on, if not on Webb, but something similar like Webb. So it's really been a pleasure to talk to you. I wish I could have been there in person. Maybe one day I will. And I hope I will see some of you here in the United States. So don't hesitate to contact me. And so I wish you all the best, good luck, and namaskar.
Thank you so much, ma'am. And yet, with your words, we can see, and this is a famous proverb in India that the earth is round. And soon, as we can see the earth is round, we cannot feel it physically, but through those waves, we can meet somewhere around you, or you will be here to guide us all. For you, ma'am, it is a good day, and here it is good night. So, with that, I will ask the Fozia ma'am to please conclude the session. Ma'am, you are not audible. Fozia ma'am, you are not audible.
You're on mute, Fawzia.
Ma'am, please unmute yourself.
You're on mute, Fawzia.
No, ma'am, you are not audible now also. Think there is some technical problem at your end. Yes, ma'am, you are.
But echoing.
It's fine, ma'am. We can understand the essence of your words.
No, I want to thank all you, Bhargav, and Kajal, and all my students, Ashna ma'am, and Vivek, and Rishi, and everybody who are sitting in the auditorium also. And one more thing, I would like to thank Fatima. Ma'am, do you know Fatima is doing all the streaming live? For the last 2 days, she is struggling with. So,
Okay, so Fatima is there on the Physics Merit tab, and she has already aspired herself that she will definitely will meet someday to the eminent personality we have for the today's talk, and we wish the same for her. Okay, ma'am, I think there is some another technical glitch at your end. So with that, thank you so much, respected Hashima Hasan ma'am, for encouraging us all with your such a wonderful words and giving us such a beautiful side today. And we think that will be worth remembering for the upcoming of your days and as well as ours who are here to attend this talk. Thanks, Department of Physics, for organizing such a curious topic and a discussion over this topic. Thank you, everyone.